So now we're going to explain the concepts between inside our setup. The most important concept is, of course, the law of conservation of energy. So the law of conservation of energy states that energy is neither created or destroyed, and it can only be converted or transferred into another form. Okay, but it's never. So the first, our concept works in every single part of this. Okay, so the first change, right, is thermal to balloon. Okay, so we burn the balloon. Okay, burn the balloon like this. Okay, so when it bursts, right, you see, right, when it bursts, right, the thermal energy is converted to kinetic energy of the air particles inside the balloon. So it will move around very quickly, hit the balloon surface, cause it to burst. The ball will then drop. When it drops, right, there's gravitational potential energy here, converts to kinetic energy as it drops, hits the box. Okay, after that, rolls to the side of the track. Here, there's gravitational potential energy here, cause it's above the ground, obviously. Then after that, there'll be kinetic energy. So after that, it will roll down. Energy is neither created or destroyed. Here, energy will be converted to kinetic energy. Okay, so there's also a conversion of energy here. Kinetic energy here, right? As it goes up, right, the kinetic energy is being converted into gravitational potential energy here. After that, it will fall down. So from here, the gravitational potential energy will be converted to kinetic energy again. It will roll down. Again, it goes up. Gravitational potential energy is kinetic energy is converted into gravitational potential energy, and it rolls down. The gravitational potential energy is being converted to kinetic energy. This when it enters the slide. Okay, enters the slide, goes into here. Okay, so now here, there's gravitational potential energy here. Okay, so the kinetic energy from here slides, goes all the way up, converts to gravitational potential energy here. After it drops, kinetic energy again. Hit the thing, this other thing, elastic potential energy. So kinetic energy converts to elastic potential energy, then it bounces up, kinetic energy again, into the cup. The energy at the start and the energy at the end will never be the same because there's friction. So friction stops the motion of the marble. Okay, stops the motion of the marble. So right, if it stops the motion of the marble, right, it opposes the force. The friction opposes it. So some of the force that the kinetic energy in the marble has is being converted into thermal energy or sound energy. Even though the ending energy and the beginning energy is not the same, mass is energy is still neither created nor destroyed, but it's converted into thermal and sound, which you cannot see or cannot feel because it's too little, or it's being converted from kinetic energy to gravitational potential energy, and that's all. So this is how our concept of conservation of energy is used here.
Now we'll explain the concept of torque in our experiment. Okay, just look here. As you can see, right, the swing, right, is currently not in motion, which means, right, the anti-clockwise torque and the clockwise torque is equal, which is why it remains motionless. But in our experiment, right, the ball comes in from a track and it enters the swing. So what happens here is that the anti-clockwise torque is greater than the clockwise torque, and thus it moves backwards. And then the ball will come. One thing to know is that it's because of the force of the ball, and it causes the anti-clockwise torque to be greater than the clockwise torque, thus moving the whole thing backwards.
Okay, so now we are going to do the concept of elasticity. So basically, when the ball is being tossed off from the swing, right, you land on this spring, and the weight of the ball will cause it to push the spring down, and thus, due to the deformation of the elastic object, right, there will be elastic potential energy, and due to the tension, it will cause the ball to be pushed back upwards and into the cup.
So at first, right, we had a huge problem. So when we heated the balloon, right, we couldn't predict where the marble would go, and we couldn't make it go through this hole. So if it doesn't go through the hole, right, it means that our experiment can't even start. So we had to find a solution. So we remembered one thing, that when we do an experiment, right, there can only be one variable. So we have to change one thing by one thing in the experiment. So we have to solve this problem first. We have to make sure that the balloon is on the same place every time we start the experiment, when we try the experiment. So our solution is this. Okay, so we poke 2 holes here, and then we put these black things inside, and we have this cross-like structure. Then we'll put our balloon here, so that it's something consistent, so that our energy. So we have a constant line outside, like it's like the marble will always drop into this thing, because we can aim the marble and position it here, so it will always be the same. Okay. Another thing you must know about the balloon, right, is that this X structure, right, gives us the consistency of having it at the same height. So why is it that the balloon must be at the same height? Because, right, there's gravitational potential energy when the marble is above the ground, as you can see. So if the energy, the level of energy when it's is different, right, then the force of it going down will be different, and the whole experiment will not have like constant results. So when we have the same height, then have same gravitational potential energy, so we can make the whole experiment much more constant. Yeah, so this is our ultimate solution for our problem of not having the marble go inside the hole.